So this is your 6-week benchmark review. The first problem and the first 5 are all conversions, okay? So we're starting out here because it's not a rate, it's just 3.2 yards over 1 because there's no other unit on the bottom. And what we want to get to in the end is feet. So if there's no conversion here, it must mean it's common knowledge, and there is a direct correlation between yards and feet. Specifically, it takes 1 yard and we make 3 feet. Why did I put yards on the bottom? Because I need them to cancel out and leave us with feet up top because that's my end goal. When I multiply this out, I'm going to get 9.6 feet over just a 1, which means that's my answer. Number 2 requires us to recall how to convert metric systems. In this case, we're going from grams, which is actually a unit, over to hectograms. 1, 2 hops to the left, okay? 2 hops to the left. So that means I take my 25,000 and the decimal there and move it 2 hops to the left. That should give us option D. Number 3 is a combination of metric conversions as well as English conversions. We start out with kilograms, but we eventually have to go to tons, which is an English conversion. Thankfully, we have given information here, okay? We start out with 3,500 kilograms over 1, and first thing we see is we've got to go from kilograms to pounds. Well, it takes 2.2046 pounds to make 1 kilogram. Kilograms goes on the bottom because I need those to cancel out. Next, we've got to go from pounds to tons. Well, pounds are up top and I need them to cancel. So the 2,000 pounds that we get from this conversion factor has to go on the bottom with 1 ton going up top. We see that our units cancel, and now we're left with just a multiplication problem. You can do this all in separate little fractions in your calculator. For mine, I have to kind of type it out like this: 3,500 divided by 1 times 2.2046 divided by 1 times 1 divided by 2,000. That's all my separate little fractions multiplied together. And when I press enter, I get 3.85 or maybe 86, but that's the only thing anywhere even in the neighborhood. So we're going with 3.85 tons. Okay? Number 4 is similar, but this time it is a rate. How do I know it's a rate? It's got the word per in it. So that means we're starting out with 10 feet per 1 second. And we want to finish the problem with miles per hour. So I've got to go from feet to miles and seconds to hours. Well, one of those is given to me immediately. 1 mile is 5,280 feet. So I use that fact. 5,280 feet is 1 mile. And I notice that now I have miles in the top, and that's what I want. So I'm done with my distance. Let's work on time. Well, I've got to go seconds to hours, which means I'm increasing the overall unit size. So 60 seconds is 1 minute. Those are going to cancel. 60 minutes is 1 hour. And now we see we've got hours and hours, so it's just a multiplication problem. You can grab your calculator and type in all your individual fractions if you would like. 10 divided by 1 times 1 divided by 5,280 times 60 divided by 1 times 60 divided by 1. And when we press enter on all that, we get 6.82 miles per hour. Okay? 6.82 miles per hour, just what we want. Number 5 is an interesting question. We've only seen it very rarely. Okay? It says 1 square foot is how many square inches? Well, a square foot, it's common household measurement, is 1 square foot is 1 foot on each side, therefore giving us 1 square foot. It's an area problem. 1 times 1 is 1. Feet times feet is square feet. But if we take that and apply it to inches, a square foot would be 12 inches by 12 inches. 12 times 12 is 144, and inches times inches is inches squared, therefore giving us A. Now, if you don't like that and the real world thought application to that, you can actually do this with our conversion bars, but it's a bit tricky. You have to know that 1 square foot is feet squared. Well, that means if we want it into inches squared, we've got to get rid of those feet. 1 foot is 12 inches. That gets rid of one of the feet, but it leaves the other one, so we have to do it again. 12 inches is 1 foot. That gets rid of our second one. We see now we have 144 inches, or inches squared. So we get the same answer either way we look at that problem. Number 6 is where we start simplifying some of these radicals. It is 900x to the 3rd power. So 900 x cubed. And we just start by breaking this 900 down. 3 and 300. You could use a 2 and a 450 if you'd like. You can use a 9 and a 100. Lots of ways to do it. 3 and 100. Some people right here go into 10 and 10. That's because 100 is perfect square. You can actually pop it out as a 10 right now. But in case you didn't see that, we can go 2 and 50, 2 and 25, and 5 and 5. We get the same answer either way. Got a pair of 3s that are coming out, a pair of 2s that are coming out, and a pair of 5s that are coming out. Also, this x cubed is x times x times x. So we got a pair of x's that are coming out. Notice the only thing that stayed behind out of everything is the x. I still have some people look and say, well, 100's behind and 50's behind 25. No, we broke those down. You just look at the very end of each branch. So everything that came out, 3 times 2 is 6, times 5 is 30. X came out, and we left one x behind. Okay? So the x popped out, and we left one x behind. Our next simplification is -9 on the square root of 216 into the 4th power. -9 on the square root of 216 into the 4th power. And I just start breaking down 216. 2 and 108, 2 and 54, 2 and 27, and then 27 is not even, so I start using some 3s. There's a pair of 2s. There's a pair of 3s, but look, we left behind a 2 and a 3. Into the 4th power is n times n times n times n. There's a pair of n's. There's a pair of n's, and this time we didn't leave any n's behind. Our pair of 2s comes out. Our pair of 3s comes out. So what we're essentially doing is 2 times 3 times 9, which is -54. N times n is n squared. My pen would write it would be. N squared. And what we left behind was 2 times 3, or square root of 6. Sorry for the pen trouble. What that ends up being is option A. -54 n squared on the square root of 6.